Hello friends, myself Vipul Patel. Our today's first topic is operating mode of induction motor. There are two mode, constant torque mode and constant horsepower mode. In this graph, you can see the characteristic between torque or power to the speed. In that, you can observe this green line indicate the torque and this yellow line indicate the power. This is a base speed. Base speed means a rated speed. Below the base speed, the torque will be constant and the power will be linearly increase. And after the base speed, the power will be constant and torque will be gradually decrease. In the constant torque mode, in this mode of operation, the air gap flux is maintained constant by keeping the ratio of stator voltage and stator frequency constant up to the base speed or rated speed. Both the stator voltage and frequency are changed simultaneously to keep the ratio constant. In constant horsepower region, the motor speed above the base speed are obtained. The stator supply frequency in increase above its rated value to operate the motor at higher speed greater than the base speed. The stator voltage, however, is kept at constant at its rated value due to increase in only the stator frequency at a constant voltage. The air gap flux will not remain constant and it will decrease. Due to that, torque is also decrease. The decrease in torque will be increase in speed. Therefore, the power, which is the product of T torque and omega, will remain constant in this region. Now, there are different speed control techniques: stator voltage control, variable frequency, constant voltage control, variable current, constant frequency control, constant voltage and frequency control, rotor resistance control, etc. Now, we are going to discuss stator voltage control. In this type of control, the stator frequency is maintained constant and only the stator voltage is varied to vary the speed of induction motor. The torque is proportional to the square of stator supply voltage V1. In this type of control, the stator supply voltage V1 is reduced from V1 to XV1, where X is less than 1. Hence, the motor torque is given by T proportional to S, that is slip, into XV1 square. Below graph shows the torque speed characteristic for value of X, for the different value of X. In this graph indicate the torque versus speed and slip characteristic. In that, you can see the different stator voltage. This first is X equal to 1. X equal to 1 is nothing but 100% stator voltage. This line indicate the torque at X equal to 1. And second is X equal to 0.75, means 75% of stator voltage. This line indicate this 75% stator voltage. At that time, the torque will be this. Now, this A and B point, these 2 points are indicate the operating point. At that time, the torque will be constant. This NS speed indicate the synchronous speed. This N1, this indicate the operating point A. At that time, the speed will be N1, and at operating point B, the speed will be N2. Here, note down that the N2 is less than the N1 speed. The point of interaction with the load torque line would be define the stable operating point. Here we see the operating point A and B. This line indicate the load torque line. So the point of interaction, that is point A and B with the load torque line, would define the stable operating point. The stable operating point means the point at which the motor torque is equal to the load torque. From the graph, the speed corresponding to the operating point A, that is corresponding x equal to 1, that is n1, is higher than the speed corresponding to the operating point B, that is n2. In this way, by varying the stator voltage, it is possible to vary the motor speed. With increase in stator voltage, the motor speed will increase. Reduction in torque and air gap flux. As the stator voltage xv1 is reduced, the air gap flux phi and torque both will reduce. This type of control is therefore not suitable for a constant torque load and is applicable where requiring low starting and narrow range of speed at relative low slip. The main drawback is the speed control is obtained at the cost of reduction in the motor torque. This type of control is suitable for both squirrel cage as well as sleep induction motor. There are some applications. This type of control used in fan, blower, centrifugal pump, where the requirement of starting torque is low. Thank you for watching this video.